So yeah, today we're gonna actually start processing data that we generated yesterday at the end of the session after we fixed the leak and everything. And also data that has been generated by 13 other labs. And we had that obviously already available. So yeah, so the first steps that we have to do now after the machine has acquired like the data would be typically some sort of like sanity check. So we want to see, okay, was there some useful information being acquired? And then we need to like convert these files. So like do like the centroiding and then conversion to like an open access format. In our case, we're going to use NZML. And then we also want to dive into like data sharing. So now important for us, we first pull this data from a repository because it is already public, right? So that enables all of us to work now with this data. But in our example from like the data that we actually acquired yesterday, that is of course not accessible yet. So that eventually we want to upload, right, and make available like to the community, to reviewers, to your collaborators and lab members, and so on. And that Allegra is going to show you how to actually do that with like the MassIVE repository. And then yeah, I'm very much looking forward to like the second part of like this morning session where Thomas Payne from Metabolites is actually also going to showcase the Metabolites repository, which is like an alternative repository run by EBI, and yeah, I think is also like a great resource to use. Besides that, there's also a couple of other repositories, and I think as long as they're fair, so like findable, accessible, interoperable, and reproducible, it's great. So there's Synodo, or there might be the Metabolomics Workbench, and I think yeah, all of them are great. Most important, and that is perhaps the big take-home message, if you can. So I know sometimes there are like trouble with like IRBs and like patient data, but if that is not a concern and you're able to like make the data public, please make it public. I think that in other communities, this is completely standard. Metabolomics, I think, is in part still like a little bit behind, but I think, yeah, like to make data accessible, reusable by others, you know, this is, yeah, quite, I think, important. So yeah, please make your data public. All right, so to get started, yeah, let's just like take a look at the things that we're planning to do with you this week. And this is kind of like the Metabolomics data analysis pipeline that some of us use, right? So again, there might be many other tools and many other ways to do things, but I think that is roughly what we have in mind for this week. And you will see there's like this different like boxes. So data acquisition, we did yesterday with the vendor software. Then we're gonna do like some data inspection. I'm gonna use now in a second also like the vendor software, but there's other open source tools like the GMPS dashboard that you can use very like yeah, quickly once like the data is in the public domain. And then yeah, later on we're gonna convert these files. Now we're gonna use ProteoWizard and MS Convert. And then Robin and Stefan will walk you through like MZMine feature finding before we then tomorrow gonna move on with like the data annotation. So we're gonna use different tools, in particular GMPS Sirius and MS2LDA. And then we're gonna do some visualization and statistics on Thursday. And then also more visualization, actually, yeah, validation. So we're gonna wanna inspect again like the data and the significant features that we found. Then for like the project work and yeah, like the preparation of like the figures on Friday. And then yeah, like at the end here, like this toolbox is data sharing and data reanalysis. I think this is really like becoming more and more important. And that's kind of like, yeah, we could also bring that to like the beginning already, because depending on like the lab and like the policies, like people make the data public right away. And I think for us, like especially like being a collaborative group, that really like also facilitates like the interaction with everybody. So like to me, like I don't know, to work with like a coworker, I don't know, like in San Diego with Allegra, right? Like if I have like to move like gigabytes and gigabytes of data each time, it's like it's really hard. But like if Allegra puts them like in the repository, I have access, then it's like, it's really simple to like, just like create like analysis from it, to like collaboratively visualize this in the dashboard. We can do this right in the web browser. And yeah, like on Friday, we're gonna show you a little bit more how to do that. Anyway, yeah, it facilitates to reproduce and to collaboratively do data analysis. Then obviously also with like the research group. So in my lab, like the policy is, yeah, there's a data set, and unless it's like some sensitive data, which we so far do not have, we make it public right away. So if you go through the MassIVE repository, you will see a lot of unpublished data from us. So now, of course, that opens up the door that we may get scooped on that, but so far it has not happened in a couple of years, and I don't expect that people actually, I don't know, like maliciously mine that like repository to like scoop research labs. Okay, and then yeah, at large, and that perhaps is the most important aspect of this, is that it makes like this data accessible to the community. And particular as like reanalysis and like meta-analysis become like more and more feasible with like emerging tools, that I think is like the really like huge power of it. So we can now set our data in context of other studies, and we can inform our own study, you know, with like, I don't know, context of like all like this other studies. So there's a couple of tools we're gonna highlight also later on that like, yeah, leverage like repository scale analysis. And I think, yeah, this is gonna become more and more important, but like we're like setting the foundation now with like making our data public. And that is not only like the annotated like library spectra, which I think is it's kind of like a no-brainer anyway. So if you annotate a feature and you find a new one, okay, put it in the spectra library. So you help others identify their unknowns, but also like the actual raw data and like the data sets you have. All right. And yeah, like one way to what we use in the lab is like the MassIVE repository. So this is hosted at like the University of California in San Diego by the mainly group of Nunu Bandera and a couple of other people. And yeah, to me, it's ease of use as the main convincing thing, because it's really simple. And yeah, like if you just like type it now in your browser, you can just like go to like massive.ucsd.edu, you know, and then browse like this public data sets. And in I think the sheet we provided was like all the links. So in the Google Drive I shared yesterday with you, in this resource document, you should find also like those links that I typed in here. But now, if you want to check it out, just go to massive.ucsd.edu and you can like already look at the interface, and you don't even have to sign in for now. So you see that there's a login option at the top. Later, if we want to submit data, you need to have an account, but for now, you don't need one. But then, yeah, if you like click on like browse public data sets, you can basically see a list of like all public data that's in there. And just find it interesting to see what like, you know, other people made public. You may see, you know, like a couple of stuff comes out after they publish, but often you also see, oh yeah, there's just like this data set and no publication out yet. So for us, very important, there is like this number here, which also is somewhere like in the slides or like in this cheat sheet, or like just click on that URL I put in there, and then it should lead you to like this particular data set here. So with this MSV number 0000900156, if you would type that in here in the search bar and hit enter, it will also like bring you directly to it. As Abser just uploaded it last week, you can also just scroll down a little bit and you will probably find it easily. So, and that is, yeah, basically contains like all the data we're gonna process today. So now you can like click on it, and then you will see, okay, there's like a description, what's in there, you know, what did we do? Typically, the more description, the better. We might have been a little bit sparse here, but anyway, yeah, it basically contains like raw and also MZML data from like this dilution series I showed you yesterday, divided in like the 13 different labs, which according to our participant sheet, you will see which lab you will be processing. And then there's this FTP link here at the bottom. And that is really mind-blowingly simple. So you just like copy that link and then paste it in like your browser. or in your Explorer with Windows, and how's it with Mac? You
go to the setup like file sharing.
Okay.
Yeah, we can add to these slides to show for Mac. Yeah.
Yeah. So with Mac, you can basically also just open that FTP link. Basically. Yeah, and then you basically will see, okay, there's like this big file structure, and apologies, it has been a little bit, I don't know, like there's a couple of like raw file folders ups are made. So you have to click through a couple of these till you then go to like this pos_MSMS folder. And then if you would like open one of these folders, you would see, okay, there's actually a couple of like .raw files. So this is the files we're actually going to start with today. There's also an MZML folder, or a peak folder, I think it's called. If you fail to like process the raw files this morning, you can then later on also just start directly from the MZML files. But yeah, to like get like the full experience, I would suggest to start with the raw files. And yeah, in case you're wondering where like all these links are again, so yesterday we shared this Google Drive with you, and there is this resources and also this participant files in there. And the resources file contains like all like the links, which you might see here, but you obviously cannot type them that quickly. And then very important, there's this participant list. And then if you open that, you will see that we assigned to each of you like a lab or a data set here, lab 1, 2, and so on. That is also then basically like the group with whom you will like work on this data set throughout the course. If you have not a lab assigned, let us know and we can just expand this list and add you in. But yeah, so now I would suggest that you try already downloading these files on your computer while we talk, and then if there's any problems, just approach us in the break and we will help you to get that onto your computer. But yeah, so now for me, importantly, I just gonna leave the presentation and go on the desktop, and then I'm just gonna start looking at the data. And here, so I just like picked now lab 15 and downloaded this already here on my desktop. You better put it in like some more meaningful folder structure, but for us here, yeah, I basically just like open it here and I can like see the raw files. So now one thing I like to do is I just want to like open those files and actually like look at the data to see, okay, is that something like useful, or yeah, what is going on here? And now I need to like open this with Excalibur in my case. So I downloaded that. Most of you won't have that software installed. So this is kind of like a step you can also do at like actually like the computer where we acquired the data, right? So let's assume I just run these on the machine and now I want to like, open it and just like take a look at it. And that's how it would look like. So yeah, this is basically like the LCMS data structure. So if you've not seen this before, this is kind of like what we would expect, because we know that this is dissolved organic matter. And that is probably one of like the most complex things we can like find in nature. So up here is like the TIC. So that's actually a chromatogram, but because there's so many peaks, you can't really distinguish any from them, and you just like see one big mountain. Also, it looks like that plaque here. Let's zoom in real quick. Because I get like the spiky peaks, right? That kind of like looks bad at the first moment when you see it, but then when you think about what we did, we run that in data dependent acquisition mode, right? So we do 1 full scan and then 5 MSMS, and the intensities are very different. So because now all of this is merged into like this one view, I actually see like all the scan events. And it becomes interesting when I now click into like one of those peaks. Then I will see here, okay, this is an MS2. And when I move with the cursor forward, then I will see, oh, here, this is actually now an MS1. So there's full MS written here. And then, yeah, like the next ones, okay, are again MS2. right? And this is exactly that type of like duty cycle that I was talking about, right? So like I get here an MS1, and then now the next couple of scans are MS2s, right? I see, okay, some of them are kind of noisy. Yeah, some of them seem like chimeric. So that's a thing we often observe in dissolved organic matter. And then hopefully, yeah, like this one, some of them there also seem to be nice. Okay, so that's overall good. So now, okay, how can I actually like extract something out of this and look at peak shapes? So with like this qual browser, I typically use like scan filters and just like remove actually all the MS. So I only look at now the full MS data. And then, yeah, this becomes already like a little bit more clear. But again, like because there's so many peaks at each time, right, I still have like this mountain. Now, if I go in at any given time point here, you know, I will see, of course, there's like different ions changing. And at some point you see, okay, I get like this background here, which I find quite interesting. So that's kind of like the, yeah, like we call like the DOM background. So this is just like the 10,000s of molecules that are in there. But then on top, there's often like nicely defined peaks, you know, and these we can still like annotate well. So I hope that even though that data is like ultra complex, we will get like a bunch of like annotations out of it. Now, okay, let's for example say the 608 here, that looks somehow promising. Let's actually look a little bit more in detail what the mass is. So it's 608, 3846. So now again, I can like create here a scan filter and now define like the mass range for exactly this molecule or like this feature. Okay. Oh, have to specify the decimals and also here the mass tolerance. So let's use 5 ppm. And then nice, you see that's really like a nice sharp peak, right? So lab 15 hasn't been us. I think it has been somebody at ETH in Zurich, but from, yeah, like that peak shape, I would say, okay, that's looks like good chromatography. We also see already a little bit the problem with the data points we mentioned yesterday, right? So now here, this is not smooth data. So if I zoom farther in, you will see, okay, I have one data point here. Let's actually see. Then I have another one here. I have one here in the middle, and I have one here, one here, one here, one here, one here. So yeah, it's more than 5. It's good, but it's still not perfect, right? But that's just like due to like the relatively slow duty cycle due to like the DDA method, right? So here, I would say that's borderline. That's still okay, but it's not great. So I don't know if Robin and Stefan can comment, but if we would have doubled the data points, it might be better, or I don't know, even triple or so, and that'd be much better. But yeah, so I think that from a first sanity check looks fine. Obviously, I hope that they also looked at the QCs before they uploaded the data and deemed it to be of high quality. So now they did not have this in the folder, so I could not check now the QCs. If this would be my own data, I would of course like check that as well. But yeah, so let's say, okay, that is good. So now I want to convert these files to MZML format. But before I do so, there was a question.
Yeah, sorry, the QCs. Do you mean like you open all the QCs and look?
Yes. Yes. Yeah.
So
yeah.
This is okay, then you know the run of file.
Yeah. Yeah. So generally, I would look at like the retention times of like the main features, or if I had like an external QC. So we typically run like a 6 mix with like 6 compounds. I just like throughout my acquisition queue, I check if like retention time was stable. If you have an internal standard, you can also use the internal standard for that, or in studies where we did not have internal standards, we used like housekeeping features. So that's like features that we assume to be in every sample, right? Like, I don't know, like phenylalanine or something like that. And then we would look like for the retention time and mass deviation there. Yeah, so, okay. So if we think that is all good and we are happy with it, now we want to convert this. And now, okay, let's see if this works here. Okay, it's not integrated yet, so I might need to start this here. So I'm going to start MS Convert. If you integrate it into like your Explorer, you can also just right-click on the files and say convert with MS Convert. Here it was not the case, so I had to just like start the MS Convert GUI here, and then you will see basically like this interface popping up. And it's relatively simple, but there's a couple of caveats that we recently learned a little bit more about that I want to share with you. So yeah, first of all, we're gonna select now the files. So here I go to browse and then go to the desktop and then go here to like lab 15. And now I just gonna select all the raw files. Okay. So then they're like listed here. Now I need to set up here what I want to convert them to. And as I said, we're going to use MZML, but there's a bunch of other file types. So you can use MZXML or like MGF. That's also pretty common, mascot generic format. But yeah, like MZML, I think is like the most up-to-date one and preferred file format for both MZMine and GMPS. So we're going to use that. Then yeah, I typically use like the 32-bit encoding precision, and then very kind of important is like I also use this zip-lib compression. It also works if you do not click that, but then your files will be a little bit larger, which particularly for large-scale studies that might be a problem. And then yeah, like write index and TPP compatibility. Okay, and now the most important part is that we need to do centroiding here. Right? And right now that is not selected. So I want to here as filter, like add peak picking. So this is the centroiding. And then I want to select the vendor algorithm. And that is particularly more efficient than the MS Convert algorithm. So we could also use here the CWT, but yeah, it's not that great. So I would suggest to use like vendor here. And then, okay, they wrote it now here. It must be the first filter. So it must be the first thing in the row. I don't know why, but like if you do any subsetting also before and then put it second, then it will like fall back to like the algorithm from like MS Convert. And I was just like explaining this to Martin here with like the that little thing. So what centroiding does, right, is like if you have, let's say, an S peak here, you know, it will pick the top of the peak. And now, like, I don't fully understand what's going on under the hood here, but like what we observed was like the CWT algorithm is, and instead of like picking here like the middle, it just like picks exactly the highest data point. So I think it does not do like a nice fitting, you know, and then picks like here the maximum, but just like goes to like whatever is the highest data point, and that can have like mass deviation of, I don't know, what was it, up to 2 ppm?
Yeah, I mean, it was like a mass of an electron, like 0.0005 or like a 400.
Yeah.
Pretty high, like 3 ppm.
Yeah.
Sometimes higher. But I don't know if it's a continuous wavelet transform algorithm or if it's a different one. At least an MZML file. So if you download some files, you can actually check that. You just go and open the MZML file in the text editor, and then they had like local maximum as the algorithm. They had like peak picking or something like a processing steps, and then local maximum. Which is, and you checked like the vendor, but yeah.
So yeah, I think it's not ideal if you know, instead of like here exactly the middle, it would, I don't know, pick like the next highest data point. And then another funny thing, I also don't understand why it does that, but if that's the case, it also adds like some 0 value data points next to it. And that is kind of a warning, which remember I've seen in the past that some software tools, particularly for like peptide spectrum matching, told me that in my MZML files, there were 0 intensity features. And it's like not understanding where this was coming from. But yeah, apparently that is connected to the problem here. So yeah, follow that rule here. It's actually written there. It must be the first filter. And then I want to set also like the MS level. So it's MS1 and MS2. And then I add this, and then yeah, if peak picking is number 1 here, then I think we're good. And then yeah, all I need to do now is I also define already here an MZML subfolder in the output directory. So it's easier for me to sort the files. And then, okay, this is the first time that we run it here. You can like convert files in parallel, and it's as if we have, I don't know how many cores, but yeah, let's maybe do 10 or something. So it does do multi-threading. And then I'm gonna save this preset as default. So then next time I don't need to like set this again, and I make sure that if somebody else on this computer is gonna use it, they don't do like any funky things. And then yeah, I just hit here start, and then it asks me if it should create like the subfolder. Say yes, and then you will see, okay, now it's writing the MZML files. And hopefully this was a fast and painless process, which again, I know with some other vendor formats, it's a little bit harder. Yeah. All right, so now this is all finished. So I can just like close this. I can check here. Okay, now there's this new folder, and I have like all like this MZML files in here. Okay, and so now this is basically now ready to either be processed with MZMine, or let's assume we just acquired this data and it's not in the public domain yet. So for us, the first step would be, okay, let's upload this to MassIVE and make a public data set out of it. And yeah, with that, I give over to Allegra, who's gonna walk you through that.
All right, so hi everyone. I don't think I've met most of you yet. So my name's Allegra, and I'm actually coming from UC San Diego. That's how Daniel and I are friends, because we were both postdocs in the same lab there. So yeah, once we have all our raw files and then we've converted them to MZML, the next thing I like to do is basically just upload them onto MassIVE directly. That way it serves sort of as, well, A, a backup for your data, B, as Daniel mentioned in the GNPS dashboard, you can start sharing the data with collaborators or friends, and that facilitates sort of easily looking at the data. So in order to upload your data onto MassIVE, you'll have to use a file transfer, so an FTP client. And so on Windows, we typically use this one, which is WinSCP. On a Mac, I like using CyberDuck. It's just a different FTP client, but they're both relatively user-friendly and pretty straightforward. So we'll show you on the PC, but for those of you with Macs, we can upload some slides showing how that's done, but I think you'll likely be able to figure it out as well. But yeah, so first thing we do is we can select FTP, and then the host name will be that same MassIVE website that we looked at earlier. Alrighty, so we can just type that in, and then in MassIVE, we each have our own login credentials, and so I believe each of you have made a login, and so I'm going to type my own credentials in here, but you can follow along and type your own as well. So All right, this is mine. All right, and so then once we've typed that in, we should simply be able to connect. Oh, no.
It's the German keyboard.
Okay, good to know. This might be the issue. Let's see. You want to help me with this real quick? I want to make sure I'm doing it right. Good to get the exclamation.
If not, I can just log in.
Yeah, maybe just log in on yours. Sorry, technical difficulties. Okay, great. So thank you, Daniel, for helping me out. I'm not used to these keywords. All right, and so now basically what we see here is on this side, we have this computer, and then here we can basically have our MassIVE, like our personal MassIVE FTP. And so here we can go to the desktop. I believe we put our data on the desktop, and then this is all the data that we just converted. Okay. So we have our MZML, and then we also have our raw files. So maybe it would be nice to just actually organize this so that we can put our raw folders in a file in a folder as well. All right, and so now we can simply make a new folder, basically on our personal MassIVE. And so we can just label this maybe with a date, and then our lab number. All right, and now we can just simply drag our MZML folder over there, and it takes a little bit of time. These are really large files, you've probably noticed. So I'll wait for that, and then we can upload the raw. And then once that's through, oh yeah.
Why is it necessary that you also upload the raw data, not only the MDML?
Okay, yeah, that's a good question. So it's not necessary to upload the raw data. I personally like to, just in case, like let's say you had some issue with your file conversion, like maybe you forgot what Daniel was saying and your centroiding has gone wrong. Also, I like having the raw data because let's say maybe something didn't go wrong, but you wanted to reprocess it, then you have it there. Once you've processed the raw data into MZML, I don't think there's really any way to go back.
No, it's really strong data reduction.
Yeah, so sometimes you might also just want to look at the data in Crawl Browser, for example, if you're looking, I don't know, if you see something funny, maybe you want to look at sort of how the collection actually looked in the raw data, just in case something was changed. So I just like uploading it to have it, because typically once I upload my data, I'll delete it from the computer where I acquired it. Yeah.
So like how long they store the data actually on the database? Is it like there is a policy that they say, okay, they store for 10 years or something like that?
Yeah, I think they store it indefinitely. Yeah. Yeah.
So once it's too much, right? Like I can use it as my all my data there, so I know.
Yeah, there has been a very
Yeah.
important update recently. So that only applies to public data. So in your user account, so where Allegra just uploaded her stuff, you have a quota of 100 gigabytes now. Because there was a problem that users would actually use this as a data.
Yeah.
And not
Yeah.
make it public, right? So they were just using the resource but not sharing. And that should be avoided with like that new quota. But there's if you make it public, you can make a public data. Then that's great for us, right? Because then we can find that to like contextualize that.
Awesome.
Yeah. Yeah. So that's a good point, is you have to make it public because now they are deleting, or now you do have to delete stuff from this, like your personal folder.
So, and the opposite, just dumping the raw files there. Why wouldn't you just do the raw?
Oh yeah, so you'll see, like for some subsequent processing, like if you, or not processing, but analysis rather, I guess, and processing in MZMine, you can use raw, but we typically use the MZML files. And then for molecular networking and GNPS, we typically would use the raw MZML files. So for, I would say most of, or nearly all of the post-processing or analysis steps, you typically be using the MZML files just because they like have already been centroided. And so you don't typically do the analysis with the raw files. Yeah, so it's good to have both, basically. Yeah. Oh yeah.
There were just a lot of questions popping up in the chat. So
Oh wow, good idea. Okay, yeah, maybe while this is uploading, we take a break. So just to look at these.
Also, like, was it information now, like what you put through? Is it possible to maybe do some screenshots, like of like how you the single steps?
Yeah. We wanted to go through it live so you could interrupt us, but after this, I'll make slides. Yeah, so as a reference. Yeah, for sure. No, for sure. Yeah, no, we'll do that.
I mean, what might be interesting for you, so while we stream it, we also record it, so we might upload it. And then
So I guess you pretty much clarified most of the questions. They were mostly just about use of FTP clients on Macs, but also MS Convert on Macs. I believe I've used MS Convert on a Mac. It's not supported? You've used it on a Mac as well? Okay.
It has changed for some reason because he asked the Paleo wizard.
Okay. Oh, just now. Oh, okay. I didn't realize that. Because I usually would usually use a PC now for MS Convert. Does anyone have any ideas about that? About MS Convert on a Mac? I guess it's not supported. Maybe we'll get back to you on that. I will, whoever is watching and ask the question. Okay. Are there any other questions while we're sort of at a pause point? Yeah.
We just have to watch that, right? Because I'm trying to keep up, but we don't have files.
Oh,
It takes really long.
oh, the download takes forever. Yeah, good point. Yeah, so maybe for now we watch and then maybe during the break, or maybe we'll even finish a bit early and we can do that right before. But let's say basically, I'll get you the slides, like I'll just do that during the break so you can have a step-by-step. Yeah, so, all right. But at the, oh yeah, go ahead.
I can't find where in the Swin SCP to create an account. I'm in Win SCP, but I can't find where I can create an account.
so you need to have
Oh,
a
yeah.
massive account for that.
Yeah, so the account you'll log in with in WinSCP is actually your GNPS massive account.
So I don't know how many of you have already one or made one. I think we suggested it in one of the emails, but don't worry, we will get back to that later. So for now, I would just suggest to watch it through and then maybe things become more clear. Oh, sorry for that.
Well, I guess maybe we just watch for now, and then during the break, maybe you can grab a quick coffee, and then we're all happy to walk around and help you out. I think that's why we have longer breaks. All right, so yes, there will definitely be more time for hands-on, but maybe at this point, I can show you how once we have our files in basically this FTP space, our own FTP space, we can find it on MassIVE to actually upload it onto the data repository. So now we can go to the same website.
Do you want to show me where they can
Oh, sure. Yeah, so making an account is pretty simple. You can either do it on MassIVE itself or on GNPS, and it would be the same account for MassIVE and GNPS. That's one reason why we actually, or why Daniel and I think, like using MassIVE as our repository of choice, as opposed to some other repositories like Metabolomics Workbench, et cetera, because we do a lot of analysis in GNPS, which you'll see later in the course, and MassIVE and GNPS, they basically talk easily with one another, or the most easily with one another. So yeah, if you would like to create an account, you can just click on that, simply register here, and then press submit. So in case you didn't have the opportunity to do that already, you can do that now. All right, so now I will have you log in. And so as you'll see then, we've added our data directly to the account that we use on MassIVE GNPS. And so you'll need to log in with the same account that you actually used for your file transfer protocol.
One thing about choosing the password for your user account, make sure to remember it or write it, because I think there is no recovery option. When it's gone, it's gone.
I didn't know that. So yeah, that's important to note. All right, so now we can simply scroll down and we want to submit our data, upload our data, but here it says submit data. We also have a variety of other options, like simply browsing all publicly available data sets, or even reanalyzing the public data, et cetera. So for now, though, we will submit our data. And clicking on that takes us to this workflow where we're simply going to add our files to a MassIVE data set. Okay, this is being a little bit slow. So yeah. Okay, here we go. So at this point now, we will create our MassIVE ID, and we'll, as Daniel showed you previously, we'll give it a title, and then we'll add a variety of metadata like species, instrument, PTMs, what lab this is from, et cetera. And this is important metadata. And then we'll also add a description. And one thing I would say is, like, it's best to have your description be like as expansive as possible for people to actually make use of your data. But let's say that you haven't published your data yet and you are nervous about someone looking at it, you can always maybe keep that more limited. And then when you publish your data, you can actually, you can modify that to make it more expansive at that point. I've talked to people who didn't want to make their data public because they were nervous about that. But then I told them, like, you don't have to have every single detail there yet. Just at the end, once it's published, then you can add more details so that your data can actually be useful. Because one thing to note is if your data is here and you actually want people to look at it and reanalyze it, if you don't provide metadata, which I think we'll talk some more about metadata throughout this course, if you don't provide metadata, like what your samples actually are, then it's actually very hard to make use of the data, right? Because at that point, it's just mass spec features. And, you know, if you don't know what this data is actually from, it's not so meaningful, I would say. So awesome. Okay, so we can then basically type out a title. So does anyone have an idea what we should call this? Anyone? So that's a good start, but untargeted metabolomics would probably be pretty much every data set in this repository, but a good start. So maybe we say untargeted metabolomics, summer school, and then we say, yeah. And then we can maybe call it just DOM analysis. Oops. And this will be lab 15. Seem reasonable? Okay, great. And then species, we can say not applicable. Or okay. Oh, it's different. Okay. Okay. Excellent. So as you can see, it's a drop-down menu, so you can start typing. And okay. Okay, perfect. All right, and then we can select our instrument. So this would be Q exactive. Yeah.
No, some have like also fibrous and I think a couple of explorers. And then there was, in the bigger study, there was a bunch of other instruments. I think in the subset, it's only all these.
Yeah, so Q executive HF. And then PTMs, I think this one probably not applicable. All right, and then for keywords, this would just be any identifiers that we could search if we're interested in looking at this data set. So maybe DOM would be one. And then we could also just write out dissolved organic matter. We can, since this is part of the interlab comparison, we can write interlab comparison. Does anyone have other thoughts? Anything else to add maybe? Yeah, that's what I was thinking as well. Anything else? Okay, yeah. Yeah, sure. All right, that's probably good. And then maybe for PI, we do you because it's the interlab study, or should we? Cool. Okay, and then it populates everything. And then at this point, we can add a description. So this is where we'll write a bit more, but we can write basically maybe Elsie. All right, so we could probably write a little more, but we're not going to be actually making this data public because the data is already there. So this might be suitable for now. I don't want to bore you by typing a long paragraph. All right, but then at this point, we can actually add our raw and our MZML files. So the raw spectrum files is where we'll add the raw, and then peak list files is where we can add our MZMLs. And so we can just click on either one of those, and that brings up this window. All right, this is taking a minute. Okay, so then it brings up this window, and if we scroll down, we see that this is like our personal space on MassIVE, like our private space. And so we can simply open that, and now we see that we've uploaded both the raw and the MZML folders onto this space. And now we can simply just transfer them from our personal private space onto the public space of MassIVE. And so we can highlight a folder that we want to select. That's sort of easier than highlighting. For some reason, this interface, you can't just like select. That won't actually work. You have to highlight every single folder. So, and then if you want to deselect, you have to re-click it to, as you can see, the highlight is going away. So this is actually important because that has caused a lot of people, you know, to actually be adding the wrong folders for their analysis. So that's why I would suggest just making a folder containing all your raw and all your MZMLs, so you don't have to select every single file. Of course, if you have 1,000 files, you don't want to be wasting your time doing that. So yeah, you can simply select your raw, and then you can click this button, and now you can double check under selected raw spectrum files. That's here. And then we can add our MZML folder here to selected peak list files. And then we don't have metadata for this lab right now. But if we did, we could add the metadata here. And then as you see, we can also add a variety of other things. For example, after we do our feature finding in MZMine, we could add that to supplementary files, for example. So I kind of like adding pretty much everything I have to the MassIVE the MassIVE data set, because then it's just all in one place. Anyone can access, if I've already done the feature finding, anyone can access that, etc. But for now, we've added our MZML and our RAWs. And so at this point, we can just finish our selection and we can confirm that we've added just the one folder we want and the one folder that we want for the raw spectra. And then we can, I would usually not add anything for these areas. So at this point, we can just submit, and then it'll take just a few minutes to create this MassIVE data set. And when it creates it, it will not yet be public. So it'll be private, and then we'll have the option to keep it private or make it public. But as we mentioned, we would encourage you to make it public, especially because if it's private and you go over the quota, then it will get, then you'll have to delete it. You won't be able to use GNPS anymore. Yeah, go ahead.
So you run one data set, and then you like rerun like the data set, or you have more data set, but it belongs to the same project.
Oh yeah.
How would you like do the data structure in a way that like it all fits into one folder? Are you different folders like to make it like clean it up so that you can?
Yeah. So I like keeping it in one folder personally, if it's like if it's the same data set, like if you maybe if you forgot to run a few samples, or like actually you realize that those samples were misinjected or something happened and you realize that, or yeah, you run a different method. Exactly. I would add that to the same data set, but it's personal preference. But I personally would do it. We can show you once this is done that you can actually add, you have the option to add files or add metadata to your MassIVE data set. And then what will happen at that point is, I can pull up an example after, but basically you'll just see a folder that's updates. So it's less organized than, you know, if you'd added everything before, but there will be an updates folder, and then you can search for those new files in the updates folder. So that's what I would personally like to do. That's what I usually do.
So yeah, this is actually a really important point, and maybe to add on to that. So the repository is static in one direction, right? So you can only add files there, but you cannot remove files. This is important because you get the DOI, so digital object identifier, and then obviously you should not be able to like delete files after you created that. So once you make something public in there, it's public. So watch out if you like select like wrong like things that you don't want to have in there, right? Always double check, you know, the selection there. So there has been stories that people made their entire private folder public, right? And then had to like, email the support stuff to get it deleted again, because they normally cannot do that. The other really important aspect is that such a data set, so for me, it evolves as my study goes on, right? Because what I do at the beginning is I like upload the raw and the MZML files, make them public, so they're like nicely accessible to the dashboard and to like all like the GMPS tools with my collaborators. But then once I have like certain like analysis products, like the feature table from MZMine, the MGF output from MZMine, you know, or then like the results from GMPS, from Sirius, and so on, I will also upload them there, and then it's like all together in one data set. And maybe later you can quickly show this in a second. When you open a new job submission and just go to the file selection, so there you will see that there's actually multiple options to deposit different files. So there's like supplementary files, you know, there's like the metadata folder, and then yeah, we can actually like throw in like the appropriate files and like folders. So there's even, I think, because MassIVE is mainly used by the proteomics community. No, there's even like gel images and stuff that you could technically upload as well, right? So this really, I think, serves as a platform to be transparent, not only with your raw data, but also with your process data. And what will be really important for us, and perhaps I can actually show this really quick, is the metadata, because for our statistical analysis on Thursday, that's something we need. And when I go quickly back to here
again, so this is the public data set I imported here in the Explorer, right? If I would go back to the root and I would see, okay, there's actually a bunch of different folders already. There is already a metadata folder, right? So Apsar also uploaded the metadata here for like the 15 labs. And then you would see, oh, there's actually here, lab 15 has already a metadata file. And that is really important. Let me open this with just with Notepad. It's just a text file, right? So you can drag and drop this hopefully into Notepad. Yeah. Oh, okay. So then let's copy this quickly onto the desktop. Yeah, nice. So now I have here this metadata information. And I think that is the key to actually make use of this data. Without metadata, this is all worthless. So that is also like a kind of like step with which I would perhaps be more hesitant to like directly make the metadata public if that is a really sensitive project where I know there's, I don't know, I might be afraid to get scooped, right? But then, you know, you don't have to do it right at the beginning, but you can do it at a later stage. And this files, this metadata that evolves, right? So like, I don't know, when I was like on a research cruise and we were, I don't know, getting samples from CTD casts, and there was like 20 other like research groups working on that same water samples and then sharing all their data. I maybe had like 100 columns here for like all like this metadata category. And this is all information about the sample, right? Then I get, I don't know, like chlorophyll levels, like salinity, pH, you know, whatever, you name it. You may get other very complex metadata, such as actually like community composition, right? So if we do in parallel sequencing, we get like an entire ASV table per sample, which for us in that sense could be metadata. Right? So now, okay, this is a very simple example. We want to keep it simple for the summer school, but these metadata files, they can be quite extensive, and only through those, I think you can actually like analyze the data. I mean, unless it's only like an A/B question or something like that. But in any more complex biological setting, yeah, you will need that. So we wrote them all for you, so you don't have to create them. But if you now start working on your own data, you know, or you maybe have own data and you want to like add this, then yeah, for GMPS, it typically has like this type of format, and it's mainly important that the headers here need to be in a certain format. File name needs to have like all lowercase letters, and then for like all like the categories here, we add like this attribute prefix. Otherwise, GMPS won't like bin data based on those. It doesn't matter so much for like the R analysis we're gonna do, but for GMPS, it needs to be in that format. You can actually also open this in Excel, which maybe makes it a little bit nicer to look at, right? Let's see.
There's also in the GMPS documentation, there's sort of an example metadata template. So when we make the step-by-step for uploading, we'll share that link as well, because metadata format has given lots and lots of people headaches, because if your metadata is not the proper format, then, or proper GNPS format, when you go to run a GNPS job, if that's the analysis pipeline you want to follow, then the job won't run. So,
but yeah, basically you have like the file name in the front, right? It's exactly like the .mzml file we converted, and then here like just different attributes for these samples. Okay, so now, yeah, if I would want to add this to the data set, I don't know if it's finished already. I can just go here back to MassIVE and check under jobs, and then we would see, oh yeah, nice. So this is finished, right? So it's done here. And then if I wanna now, yeah, look at it, then I can click on it, and then you will see here it's still private, right? So it's not visible to like the public. I can make here, click make public, then it will become actually public. So let's just do this now as an example, and then oops, it will now get here this green tag, so it's public. And if I want to add now this metadata, I can just like go to add files. There's also this add update metadata button. It's a little confusing because this only means that I can now change the general description of the data set. But if you want to add a metadata file, you would need to go to like add files, right? So let's say if I want to add another, now, I don't know, with metadata tag, then, you know, I could just like add this here and then update it that way. But that is not, you know, that is not adding that metadata file. So that just like adds the description here. So in order to add the metadata file, I would actually need to go to add files. And then I go back to that interface that Allegra just showed you. And then actually we can just quickly do it here. So I would drag and drop this metadata file now into, where is it? WinSCP. You know, and then now it's small, so it should be there rather quickly. And then when I go to now here, select files, I can select here this metadata file, and this should be now visible in my folder here. So here, metadata, DOM interlab lab 15. And now I can add it here to metadata, right? And finish selection, and then submit. And now, oh no, I have to add a description as well. I think it needs a minimum number of no. All right. And now, yeah, it will write like an update folder within this data set, and now there will be also the metadata available. It will always create an update folder, so it's also kind of like visible that this was not added from the beginning, but was added at a given time point later on. But yeah, so I think it's really, I think it's useful to think about this as a dynamic, evolving data set, right? So now we can actually do this. Like later when Robin and Stefan are done with their processing, you know, we can upload the MZMine output files, and then tomorrow we can add on the GMPS series and MS2 LDA files too. And then it really becomes like this one place of like having all like the data together. And honestly, like reviewing papers and seeing in the data sharing section that all this source data is publicly accessible, that adds a ton of transparency. And that indicates that, first of all, like people like knew their stuff, and they're like actually care about that you can reproduce what they did. And unfortunately, often it's not the case. There's like some processing happened, and there may be a final output table in Excel, but how they got there, you know, it's kind of like a black box. I hope that this really adds transparency there. But yeah, cool. All right.
There's a question online from you, if you can share some screenshots about Thanks Convert, because she missed the first 30 minutes, but I found online on YouTube your own video about my Thanks Convert.
Yeah. So there's a lot of material. Also on the GMPS documentation, there's a lot of like infos, and then we will make this recording from the summer school also available, so then they can just watch that.
I'll do some
Yeah. Awesome. Cool. Are there any questions? Again, yeah, if you want to try this later on for your own data, let's do this as a test, and then if there's questions, just approach us during the breaks.